to 0 from the right of 6x plus 1 to the power of cotangent x.
Excellent. 6x plus 1 to power cotangent x. Brilliant. When we're asked to find a limit, what is the first thing most of the time? Because we had situation in which we had to perform some algebra before doing that. So
plug in
yes, yes,
A.
yes. So 6x plus 1 when x approaches 0. Where is this going?
One.
Exactly. When x approaches 0, remember cotangent is cosine x over sine x. So there is a problem because cosine approaches 1 and the denominator approaches 0 from the right. So this is like 1 over x. So it goes to infinity. As x approaches 0 from the right, 1 over 0 approaches infinity. So this is the one of the powers which are more involving. These are the most cumbersome ones. What is the procedure for that?
To name,
We could turn into a quotient.
Yes, but what is the first step? Yes, that's
we take the what's called natural log.
yes. So first we name the function. Exactly. Then we apply natural log to both sides and bring cotangent down. Now we do what? I name the function, I apply the log to both sides of this equation if you want. Then what do I do next?
You bring cotangent x below that natural log x.
I cannot do that. I have to apply the limit next. So in step number 1, I name the function. In step number 2, I apply natural log. In step number 3, I apply limit to both sides. Limit as x approaches 0 from the right, from natural log y, is the limit of this. And yes, now, because I realized that this, when x approaches 0, this approaches natural log 1, which is 0. And cotangent is cosine over sine. When x approaches 0, this approaches infinity. So I accomplished a lot. I changed this most difficult, I would say, indeterminate case into 0 times infinity, which only, as you just said, Aaron said, just manipulate the function a little bit, muscle it a little bit to change it into a ratio. That's it. That's exactly it. Because this is exactly what it requires, what it needs. It needs a muscle a little bit. So limit as x approaches 0 from the right, we will let natural log 6x plus 1 over. So if I have cotangent, I know that cotangent is 1 over tangent. So 1 over tangent is cotangent. I kept natural log as is. It's in the numerator. It's where it should be. Now I will plug it in again. And I know that the numerator goes to 0, and I know the denominator goes to 0, and I'll say, yay. Why am I saying yay? Now I can finally, after all these steps, I can finally apply L'Hopital's rule. Can anyone apply L'Hopital's rule for the top?
It would be 6 over 6x plus 1.
Yes, excellent. And can anyone apply L'Hopital's rule to tangent?
Secant squared x.
Very good. And it's done. How come? Okay, let's try. Let me write it one more time because this is secant over 1 and I have to flip it. So limit as x approaches 0, 6, 6x, 6x plus 1, and secant squared x. Why is it done? Because the numerator goes to 6, this goes to 1, it's 1 over cosine, and cosine is 1 at 0. And this is 1. So the answer is 6, but the answer is not 6. Now in step 4, I have to copy the beginning, swap the operators, and copy the end. So you can swap already if you want. Limit as x approaches 0 from the right, from y, which was 6x plus 1 to cotangent x, is 6. So I already swapped the operators. Limit as x approaches 0 from the right of y, but I replaced y already, is 6. So this is an equation now. And I have to solve for this. How much is this? For the natural log of this to be 6.
E to the power of that.
Exactly, e to power 6. That's it. Limit as x approaches 0 from the right, from 6x plus 1, cotangent x is e to the 6th. And now I can say done. Any questions, please? Very good question, very good problem. Thank you. So please remember the steps. You will have a problem like this on the test. There is no question about it. Please follow these steps. Number 1, name the function. Number 2, apply natural log. In step 3, this is an equation. In step 3, you apply natural log to both sides and you continue to simplify the right-hand side. You get this, you copy the beginning and the end. And then you say e to power 6 equals this. Very good. Perfect. Other questions? Anything else you would like to continue with? Anything else? Okay, back to the list. Any preference, anything, any questions?
What section was the Newtons?
4.8, the last one. So Newton's, please in WebAssign, do not determine more than one. I'll give you full credit for any equation. If there are 4 solutions, please determine just one. I know the WebAssign will consider wrong. I'll give you the points. I don't want you to.
Maybe that's
Yeah, just one.
I have them on WebAssign.
I'm ready.
Where I'm trying to find the work so I can try and figure out my error.
Yeah, so this is Newton's method is in 4.8.
Yeah, so it's use Newton's method with the specified initial approximation x sub 1 to find x sub 3, the third approximation to the solution of the given equation, round to 4 decimal places. And it's 2 divided by x minus x squared plus 1 equals 0, and x sub 1 equals 2.
Good. Perfect. So this is our function. They already gave us the starting point. I don't have to use the IVT anymore because they gave us the starting point. We have to use IVT when I have to discover the interval, the 1 unit interval. And I have to say the function is continuous, blah, blah, blah. And it changes sign between this and this. And that's why by IVT there is a solution. There is no need. If they give us this, which I normally, if you remember, I don't like that. I like this, but it doesn't matter. It's the same thing. So I have f of x, which is 2 over x minus x squared plus 1. And I have to find f prime of x. Remember this? Negative 2 over x squared minus 2x. So I know that the function that I need to put in the calculator is this. Function 2 over x minus x squared plus 1 over its derivative. Look at one thing here. The derivative has two terms and both of them are negative. I'm going to do this. In other words, I factor out negative 1 and I replace the negative by positive. Okay. Now, I have to check whether x1 equals 2 makes this 0. Because if it makes this 0, I'll say, sorry, I can't start with that. No, it doesn't, of course. They check that. So it's 2 over 4 plus 4. It cannot be 0. So I enter this function as is in the graphing calculator, and I will start with x1 equals 0. So let me see. I have my calculator here. I am entering the function. Careful with this function. So x, and then plus, parentheses around the numerator, 2 over x, minus x squared plus 1, close, divided by, parentheses again, careful, 2 over x squared, and then plus 2x, and close. Now I go out of there with second and quit. I go to variables. I go to the right, y variable. I'm calling the function. Which function? Of course, y1, that's all I have. I will plug in 2. And I get x sub 2. 1 point, how many 5s? 1, 2, 3, 4, 5, 6, 7, 8. 2, 4, 6, 7, 8, 6. Then the next step is the only one that is different, and then everything else will be the same. So I will make the calculator insert the previous answer. This one, all this gibberish here. So press enter, and this is my x sub 3, 1.5215151181, and I can continue whatever. I'm not sure, they only wanted this one, I guess. So this will be x sub 4, 1.521379709. So if they only want the third one, and they want 4 decimal digits,
Yeah.
then I have 2, 4. $1.5215. Is that okay?
Yes.
Perfect.
I found my error. I messed up the sign when and
Yeah, that's why be careful, because Newton's function has minus here. But why minus and minus and minus, and who knows what I copy?
Well, I kept the minus, but then I didn't make it addition. I kept the minus, but then when entering it into my calculator, I forgot the negative in the numerator, so that screwed up my whole answer.
Uh-huh. Okay. Good. Next question. Anything else you would like to continue with? Anyone? Anyone that needs help with the WebAssign, with anything else? Which topic would you like to continue with?
Oh, I was thinking about like 4.7.
Yes.
I'm not good at those ones. I guess like on WebAssign.
You mean, yes, any problem, yes.
I was thinking about like question 11 on WebAssign.
Do I need to open it?
I think I can explain it. It's where like there's a piece of wire that's 18 meters long. It's cut into two pieces. One piece is bent into a square, and the other is bent into an equilateral triangle.
Okay, so the square and the equilateral. Good. So, and how long is it again?
18 meters, and it's a two-part where one is trying to maximize and one is trying to minimize.
Good.
The total area.
Good. So we need to look at the total area. Perfect. So this is x and this is y. And we know that x plus y equals 18. This piece will be converted into a square, but since the length is x, the side will be x over 4. So the area of the square is x over 4 squared. Now, the other side is an equilateral triangle, meaning all three sides are the same. Since this whole measure is y, then I have y divided by 3, y divided by 3, and y divided by 3. Now, how do I determine this area? So I'm going to call this A1 and I'm going to call this A2. And of course, the total area will be A1 plus A2. So in order to find the area of an equilateral triangle, remember one thing, that not just the three sides are equal, but also the angles are all 60 degrees. 60 times 3 is 180. So in order to find the area, I have several options, but one of them is the easiest. So in any triangle, if we are given two sides and the angle in between, which I do, y over 3, and the angle in between, we determine the area as 1/2 y over 3 times y over 3 times sine 60 degrees times sine of the angle in between. So 1/2, the measure of one side, times the measure of the other side, times the sine of the angle in between the two sides. So this A2. So A2 will be y squared over 18, 9 times 2. And sine 60 is the square root of 3 over 2. So A2 will be y squared, the square root of 3 over 36. Any questions so far? So then the total area, TA, is x squared over 16 plus y squared, the square root of 3 over 36. One of these two has to go away because I can't continue. And it doesn't matter which one goes away. I have an equation that will help me remove one of them. If we decide to remove y, then I will replace it by
18 minus x.
yes. And of course, I'll have to square that in here. Finally, I can say that this is a TA of x, which is x squared over 16 plus 18 minus x, everything squared, the square root of 3 over 36. I'm happy. I have the function. What now?
You get the prime of that.
Yes. Ta prime will be 2x over 16, so it's x over 8, plus the square root of 3 over 36, because I'm not going to differentiate this. It's a constant in front of the function. And I differentiate this to 18 minus x to 2 minus 1 times the inner function prime, -1. Okay, I have the function, I have the derivative. Good, lucky me. Now what?